Determine the nature of the stationary points for the function y equals 2x to the power of 3 minus 12x squared plus 24x minus 13. So the first thing we want to do is calculate what dy dx is. And using power at the front 1 of the power to differentiate each of these terms, we find that this is equal to 6x squared minus 24x plus 24. Next, to find the stationary points, we want to solve the derivative equal to 0. So we want to solve 6x squared minus 24x plus 24 equals 0. And now we can recognise that 6 is a common factor of all of these terms, so we can take that out as a highest common factor, leaving behind in brackets x squared minus 4x plus 4 is all equal to 0. If we inspect the trinomial, you can look for the factors of 4 that add up to negative 4, and that is negative 2 and negative 2. So this can be written as 6 times x minus 2 all squared is equal to 0. Using the null factor law, we can write x minus 2 is equal to 0, and adding 2 to both sides of that equation gives x equals positive 2. So there's only one stationary point on this function. So with that in mind, we only need to separate this table into 3 sections. In the middle, we'll put the x value of 2, where we know there's a stationary point, so we know that that has a derivative value of 0, and the sign of that is 0, so it's a stationary point. And then on the left-hand side, we need a number smaller than 2, so I'm going to select x equals 0 as a very easy number to evaluate. Then we need to find the value of dy dx when x equals 0. And substituting that into the derivative, we find that that's 6 times 0 squared minus 24 times 0 plus 24, and that is simply equal to 24. So the value of dy dx is 24, which is a positive value, so it has a slope that's going up. And then we also need to find the value of dy dx, the derivative, when x is equal to, and a number bigger than 2 is 3. So we'll find dy dx when x is equal to 3. So when we substitute that in, we'll have 6 times 3 squared minus 24 times 3 plus 24. And when you evaluate that, you find that that is equal to 6. So the value of the derivative when x is 3 is 6, and that is a positive value, so it would be sloping this way as well. So if we inspect the slope diagram, it goes positive, 0, positive, which means that at x equals 2, we have a stationary point of inflection.